All right, let's dive in. Today, we're going to unpack one of the most transformative technologies of our time, artificial intelligence. We're going to go on a journey, starting with the original dream, digging into the nuts and bolts of how it all works, and landing on the very real consequences it's having in our world, right now. To really get where AI is going, you have to appreciate just how ambitious it was from the very start. Take a look at this prediction. It was made way back in 1965 by an AI pioneer named Herbert Simon. I mean, wow. That was breathtakingly optimistic, and it just perfectly captures the dream that's been driving this field for more than half a century, to create a machine that has the intelligence of a human. But that brings up the most fundamental question, right? When we throw around that term, artificial intelligence, what are we actually talking about? What does it even mean?
Let's go right back to the beginning. This definition from the 1955 proposal that literally gave the field its name is just so beautifully simple. The goal was never just to build a better calculator. Nope, it was about mimicking the whole shebang, the entire spectrum of what we consider intelligent human behavior. We're talking learning, reasoning, solving problems, and yeah, even creativity.
The early years were, well, a total whirlwind of progress and setbacks. In 1951, we saw the first ever neural network, a machine that simulated a rat learning its way through a maze. Then the field got its official name in '56. But then, reality hit, and it hit hard. By 1969, researchers basically ran into a brick wall, realizing just how limited their simple models were. This kicked off what we now call the first AI winter, a time when funding and interest just dried up. But still, there were these little glimmers of hope, like programs that could understand simple commands that kept the dream alive. Okay, so let's get into it. How in the world did we leap from those early, kind of brittle systems to the incredibly powerful AI we have today? Well, the secret sauce is all in how these machines learn. For the most part, it comes down to two primary methods. First, you've got supervised learning. The best way to think about this is like giving a computer a massive stack of flashcards, where you give it both the question and the answer. It learns by example, so it can then make predictions on new stuff it hasn't seen before. Then, on the flip side, you have unsupervised learning. This is more like giving the AI a giant, messy library and just telling it, go find your own patterns. It has to sort all the books into genres without any pre-existing labels. And the third major method is reinforcement learning. This is pure trial and error. An AI agent, maybe it's a robot learning to walk or a model learning to master a video game, it just tries something. It gets a reward for a good move or a penalty for a bad one, and it adjusts its strategy. You do that millions of times, and eventually it discovers the absolute best way to reach its goal. So what's the engine powering all of this? Well, it's pretty much all based on artificial neural networks. Systems that are loosely inspired by the billions of connected neurons in our own brains. Now, when you stack these networks into huge multi-layered structures, you get what we call deep learning. And this is the crucial breakthrough. Each layer learns to recognize more and more complex features. The first layer might see pixels, the next sees edges, the one after that sees shapes, until a really deep layer can recognize something like a face. It's this hierarchical learning that unlocks these incredibly complex tasks, like understanding what you're saying or finding a cat in a photo. So here's the crucial point. Where does all this complex learning technology actually show up in your life? The answer, you might be surprised to learn, is just about everywhere. And this just shows you how deeply AI is already woven into the fabric of our modern world. I mean, look at healthcare. It's dramatically speeding up the search for new drugs. In transportation, it's the brain behind self-driving cars, and it's optimizing global supply chains. And in our daily lives, it's powering your smart assistant. It's behind the recommendations on Netflix, and it's running the translation apps that connect our entire world. But when a technology gets this powerful and this widespread, you have to look at the other side of the coin. With all this incredible capability comes immense responsibility and some really serious challenges that we are only just beginning to get our heads around. You see, these algorithms, they aren't created in some sterile lab. They learn from data that we humans generate. And let's be honest, our world is full of historical, systemic, and unconscious biases. So the critical question isn't if bias gets into the code, but what happens when it does, and how a seemingly simple algorithm can amplify real-world inequity on a massive scale.
And this is not some theoretical problem. Here's a stark, real-world example. A major healthcare algorithm used a shortcut that seemed logical. It assumed that patients who cost the system more money must be sicker. But because of long-standing inequities in healthcare, less money was historically spent on treating Black patients. So the algorithm learned to incorrectly see them as healthier, and it systematically locked them out of programs designed to give people extra care. Now, what's really incredible about this slide is the impact of fixing that one flawed assumption. Before the fix, only about 18% of patients identified for extra care were Black. After researchers went in and corrected that bias, that number more than doubled to over 46%. That's not just a statistic changing, that represents a profound, life-altering impact on people's health. And what makes this all even trickier is something called the black box problem. Honestly, this is one of the biggest challenges in AI today. Deep learning models are so complex, with millions or billions of connections, that even their own creators often can't explain why a model made a specific decision. For example, an AI got incredibly good at spotting skin cancer, but it wasn't because it understood medicine. It turned out it had just learned that photos of cancerous moles, which were sent in by dermatologists, often had a ruler placed next to them for scale. The AI didn't learn to spot cancer, it learned to spot rulers. And that lack of transparency has terrifying consequences. Imagine that kind of faulty logic in a system deciding who gets a loan or who gets parole. If the AI says no, and we can't figure out why, how can we possibly check for fairness or even basic common sense? So you take all of this, the mind-blowing power and the really profound pitfalls, and it brings us to the biggest question of all. Where is this technology headed, and what kind of future are we actually building with it?
Okay, get ready for this number, 2050. According to the median forecast from hundreds of AI experts, there is a 50-50 chance that by the year 2050, we will have AI that can do almost any task better and more cheaply than a human can. Just let that sink in for a moment. One of the most significant transformations in all of human history could very well happen within many of our lifetimes. And that potential future is forcing some really urgent society-wide debates right now. We're talking about massive job disruption, with estimates that up to 300 million white-collar jobs could be impacted. At the same time, we're seeing entirely new jobs pop up, like AI ethicists and prompt engineers. We're also seeing this global scramble to create laws to govern the technology. And maybe most importantly, we're facing these fundamental questions about power. Is AI going to be a tool for shared prosperity, or is it just going to deepen the gap between the haves and the have-nots? Which leaves us with a final, provocative thought to chew on. As these systems become more and more capable of learning and reasoning and even creating in ways we don't fully direct or even understand, we are forced to confront a question that used to belong in science fiction. Where exactly do we draw the line between a really sophisticated tool and a genuinely autonomous being? That is the question we will all be answering together.